I can still do that.
Okay. So I'm starting problem 1 from 8.3. I have y double prime plus 3y prime plus 2y equals e to the t. And I need to recall some facts. So, oops, that's not. So, fact, off in the margin here. The Laplace transform of y double prime is s squared cap y minus y prime at 0 minus sy. I don't know why I have to stupidly write so far off in the margin. Minus sy at 0. The Laplace transform of y prime is s cap y minus y at 0. Okay. Everybody good with facts?
Yeah.
Okay. Further, you may add those to your inverse Laplace transform sheet. I would very much recommend doing that. It sucks if you get those wrong. So put them on the Laplace transform sheet so that you're not having to like vaguely recall them and get a minus sign wrong or something. Cool?
Yep.
All right, so if I take my equation, I Laplace transform everything in sight. I should be Laplace transforming y double prime plus 3 times the Laplace transform of y prime. Make sure to not forget the parentheses that are kind of implied there. Plus 2 Laplace transform of y is equal to Laplace transform of e to the t. Okay, one of these things is in the table and one of the others is easy. Which is the one in the table?
The e to the t.
Good. E to the t is line like 5 on the table.
Yeah.
So I get 1 over s minus 1. I'm looking at the e to the lambda t line, right? And then one of these others is easy. That's the Laplace transform of y, which is capital Y. Then the others are kind of written off in the margin here. So the Laplace transform of y prime, right? So I should have 3 times, let's see. So looking over here, Laplace transform of y prime is s capital Y minus y at 0, which is, in this case, 1. Questions? Okay. All right, so then the Laplace transform of y double prime, I need a s times y at 0, so that's an s that I'm subtracting. I need to subtract y prime at 0, so that's adding 6. And I need s squared capital Y. Good with that?
Uh-huh.
So this one those 3 terms came from this guy. These 2 terms came from that guy. That one turns straight into this, and that one turns straight into this. Okay, so what's my next step then?
Should be or combine like terms. That's
yeah, combine like terms.
Yeah. I just need to smash all this crap together, right?
Mm-hmm.
So I think I have an s squared capital Y plus 3s capital Y plus 2 capital Y. And then I have a +6, a -s, and a -3. And all that crap's supposed to equal 1 over s minus 1. So on the left-hand side, I want to factor. So I have y times s squared plus 3s plus 2. And then I have plus 3 minus s is 1 over s minus 1. Everybody good?
Yep.
Okay, so then I have a y, and that thing factors into s plus 2 times s plus 1. And this is supposed to equal 1 over s minus 1 plus 3 minus s. Oops. I did something stupid.
It's a negative. It's -3 minus s or plus s.
Yeah, so it's s minus 3. Right, because I need to subtract 3 and add s to both sides.
Yep.
Okay, so next thing next.
Divide by the s term.
Perfect.
On the left.
So you get y times 1 over s minus 1 times s plus 2 times s plus 1 plus s minus 3 over s minus 1. Oops. Not that. What should the s minus 3 be over?
S plus 2 and s plus 1.
Perfect. Okay, and this is the part where your like algebra 2 skills will either make your life a lot easier or a lot harder. Because from here I really need to inverse Laplace transform this stuff, which means that I have some options. I can either do a lot of partial fraction decomposition, like one partial fraction decomposition on each thing, or I can try to hope for something to cancel. I don't see anything that cancels right now. So what I'm going to do is I'm going to stick these fractions together so I don't have to do 2 PFDs. Does that thought process make sense?
Yep.
Look for the cancels first, though, because it will make your life easier if something cancels.
Is that why you didn't just have a common bottom before you divided by the left side?
Yep.
Okay.
Yeah, because if something cancels, like in the one that, in the other one that we just did, number 6, the top of one of these terms just swipes out one of the bottoms. And then it makes it something I can inverse Laplace transform right away. So if you can get a cancel there, that's the best option. Otherwise, you have to stick this crap together and try for this kind of big PFD.
Yeah, that was some intense.
That was perfect.
Right there.
All right, so in order to make this thing work, I'm going to multiply this second term by s minus 1 on top and bottom. Right, just to stick everything together. And so this crap is going to turn into s squared minus 4s plus 3. So after finding my common bottom here, I've got s squared whoops. I have s squared minus 4s plus 4 all over s minus 1 times s plus 2 times s plus 1. Right? And then at this point, you could hope for something to cancel again. In this case, I'm not seeing it. So my hope would be that I could like factor the top. The top in this case factors into s minus 2 quantity squared. And I really want to cancel one against the s plus 2 on the bottom, but you can't. If you could, it would make your life easier, right? Everybody see that?
Yeah.
Okay, so instead I'm going to do partial fraction decomposition. So I'm thinking this thing looks like a over s minus 1 plus b over s plus 2 plus c over s plus 1. And this, my dear Francisca, is where the Heaviside method is going to shine. Because in this case, I get s squared minus 4s plus 4, which is going to equal a times s plus 2 times s plus 1. That was supposed to be.
So you would set them equal to 1, 2, and negative 2?
Yeah, 1, negative 2, and negative 1.
Oh, sorry. I keep forgetting. I'm behind. This stuff is delayed, but I just saw Glenn's thing.
Okay, so let's see. I got my A1, I got my B1, and the C needs an S minus 1 and an S plus 2. Okay, so when S is 1, I have 1 minus 4 plus 4 is 1 is equal to, and then I got A times 6, and then the B and the C term are 0. And then when S is negative 2, the left-hand side is 4 plus 8 plus 4, which is 16, I think. And that's going to equal the A term and the C term are 0, and the B term is times minus 3 times minus 1. And when S is negative 1, I'm going to get 9 is equal to, and that one's only about the C term, and that's going to be negative 2 and 1. So out of this, I got A is a sixth, B is 4, and C is negative 9 halves. You guys all see that?
Well,
Yeah.
I don't, but...
Okay.
I just posted
Oh,
it.
no, wait. Yes! Yay, Glenn. You're amazing.
Okay. So I'm basically, I just, use Heaviside's method to make my equations as easy as possible, right? And then once I've got the coefficients, like you could multiply all this crap out and then collect like terms and then equate things if you wanted to. That would work in this case. But at the end here, I have y is equal to 1/6 times 1 over s minus 1 plus 4 times 1 over s plus 2 plus negative 9 halves times 1 over s plus 1, right? And then inverse Laplacing everything, I get little y is 1/6, and then I need to inverse Laplace 1 over s minus 1. That one should be easy.
Is in A to AT.
should be e to the t in this case.
Yeah, because it's 1. Yeah.
Because the a is 1. And the reason I know that one should be easy is that's the one I started doing. That was the right-hand side of the equation originally.
Right.
So that thing should almost always reappear here. And then I have 4 and e to the minus 2t and minus 9 halves e to the minus t. You just have to remember e to the lambda t goes to 1 over s minus lambda.
Hey, Joe.
Yeah.
How did you get 4? Or for B, how did you get 4?
6.
Negative.
Oh, because I'm an idiot. Why'd you let me do that?
Could be.
Okay, thank you, Cody. That should be this multiplies to 3, not 4, and so B is 16 thirds. And the nice thing is that actually just translates all the way through. Thank you, Cody.
Yeah.
Anything else I screwed up? Because I'm sure there was something. Hearing none, I'm going to erase a little bit and rewrite this. And guess I'll write that in purple. Okay, and then I'm going to do this. Circle these. So while we're kind of generally discussing this, why is this preferable in some ways to my previous solving of constant coefficient second order linear ODEs? Oh, I forgot a word. Pop quiz. What word did I forget?
Buckle chode?
Oh, ordinary differential equations?
This one in particular was non-homogeneous, right?
Non-homog?
Non-homog.
Yeah, so this isn't a twackle chode, this is a twacklin chode.
Oh.
That's what I said. I think it just broke up a little bit.
Oh, yeah.
Definitely.
So...
Because the other one was hella long and gruesome and literally looked like hell, and this is really nice and cute and sweet.
Yeah, I mean, this still has...
Cancellation happens. You don't have to find all your cancellations.
Yeah, you don't need to kind of force yourself to go through method of undetermined coefficients, right? You can just do algebra instead.
Yeah.
Or variation of parameters, of course. But yeah, this thing, it is a bit easier. The only problem with it is that the technique, right, of using this partial fraction decomposition really relied on me knowing those initial values up front. You guys see that?
Yeah.
Like if I scroll way up here and think about where did I use my initial values initially, or like where did I use them? I used them up to compose these terms that I've circled up in green there.
What initial values are those?
That's
Your y prime and of 0 and y of 0.
Yep, exactly. And
That just is the general Laplace transform thing, though. Oh, the original thing that you had up there. Okay.
yeah, and so I needed those at the beginning, and if they had been different, then this whole process would have changed, right? Because those initial values are where I got that 3 minus s down a couple lines. And that's where I got the thing that I was partial fraction decompositioning, right? And that's where I got my A, B, and C. And that's where I got the coefficients for my final answer. Does that kind of make sense?
I think so.
Like, if I had different initial conditions, I would have different decompositions, and then I would have very different coefficients at the end.
But they're like initial conditions that are like different than what we've been used to with like the initial value problems. I think that's what I'm getting hung up on. This
Oh, no, I'm sorry. They're the same. They're the initial values. Initial conditions, initial values are the same thought.
Wait, are we given that on this problem?
Yeah. Yeah, we were given.
Oh,
And we use them to Laplace transform y prime and double prime.
I get it.
And what I'm saying now is that one of the weaknesses of the Laplace transform technique is you have to know those things ahead of time, or else it changes the entire method of the problem.
Because we wouldn't be able to do this had we not known these numbers, right?
Yeah. And the other method lets you solve more in general, but then plug in initial conditions and get numbers later. This technique doesn't lend itself to doing that. Does that kind of make sense?
Yes.
Yeah.
It's got a big payoff, and there's a good reason to do it, but it does have this one weakness.
Can we go over 21 real quick? With
Yeah.
the little time we have left.
Let me pause this video. So.
Man, they're